Okay, sample problem 313. Aspirin, which is acetyl salicylic acid, has a chemical formula C9H8O4, is the most commonly used pain reliever in the world. It is produced by the reaction of salicylic acid, C7H6O3, and acetic anhydride, C4H6O3, according to the following equation. 1 mole of salicylic acid reacts with 1 mole of acetic anhydride, and that forms 1 mole of acetyl salicylic acid plus 1 mole of acetic acid. Okay, so the balanced equation has coefficients of 1 in front of every reactant and product. In a certain aspirin synthesis, 104.8 grams of salicylic acid and 110.9 grams of acetic anhydride are combined. Calculate the percent yield of the reaction if 105.6 grams of aspirin are produced. Okay? Limiting reactant problem, and also a percent yield problem. So this one is about as involved as a problem that you're going to do in this entire course. So if you find this particular problem challenging, that makes sense. This is one of the more challenging type problems that we would do in the first semester of chemistry. If you take the second semester, there'll be some problems that are equally involved or perhaps even more involved. But this one for this course is probably about as involved as it gets. So there's only one question. It just says, what's the percent yield? So we'll go ahead and point out that the percent yield can be calculated by taking the actual yield dividing that by the theoretical yield, and then multiplying that by 100%. Okay? They tell you that 105.6 grams are produced. So that 105.6 grams, that's the actual yield. So we know that value right now. But we need to divide that by the theoretical yield. Times 100. Just a little tip, when you do theoretical yield problems in textbooks, the answer is almost universally 85, 90, 95%. Now, you might be able to find some examples that are different than that, but that's usually what the answer is. It's going to be like 85 to 95%. It's not going to be over 100, and it's not going to be below 80, most likely. So if you get an answer and it comes out to 2%, or you get an answer and it comes out to 120%, that'll tell you something's wrong. It's usually pretty high, close to 100, but maybe not right at 100. Okay? So here's how we go about it. The theoretical yield, that's the key to this problem. You have to be able to calculate the theoretical yield. The theoretical yield is essentially just the limiting reactant problem, just like the previous example. So this problem is, quite frankly, just like the previous problem, sample problem 312. So if you need help with 312, if you need help with this one, you may need to go back to 312 and take a look at that one. So here's how we go about it. We have two compounds that are reactants. There's salicylic and acetic anhydride. So just like in the previous example, what I'm going to do is I'm going to calculate the molar masses of each of these. So salicylic acid is C7H6O3. So that's 7 times 12.01 plus 6 times 1.01 plus 3 times 16. Okay, so 763. 7 times 12.01, 6 times 1.01, 3 times 16.00, and you get 138.13. Again, it's in grams per mole. That's the units of molar mass. Now I'm going to calculate the molar mass of the second reactant, which is acetic anhydride, which is C4H6O3. So that's 4 times 12.01 plus 6 times 1.01 plus 3 times 16.00. Okay, so 461. 4 times 12.01 plus 6 times 1.01 plus 3 times 16.00, 102.10. Again, grams per mole. Okay, that's a difference of 36. That makes sense. Okay, so now let's go through and figure out which one is the limiting reactant and how much aspirin is going to, oh, we do need to have the aspirin, sorry. The acetyl salicylic acid, which is the aspirin, is C9H8O4. So we need that too. So 9 times 12.01, 8 times 1.01, 4 times 16.00. Okay, so 981. So 9 times 12.01 plus 8 times 1.01 and then 7 times 16.00. 228.17. Oops, sorry, I got the wrong formula. It's 984, sorry. 9 times 12.01 plus 8 times 1.01 plus 4 times 16. 180.17. Interesting fact is that the molar mass of aspirin is pretty darn close to the molar mass of glucose. Glucose is 180.18. Aspirin is 180.17. Pretty close. Okay, so now we're going to figure out how many grams of the aspirin, remember this is the aspirin down here, how many grams are going to be produced from each of those reactants. Luckily the balanced equation is 1-to-1 stoichiometry, so that's easy. So let's go ahead and figure this out. We have a reaction between 104.8 grams of salicylic acid, which is C7H6O3. 1 mole of that is 138.13 grams. Okay, so 104.8 divided by 138.13. 104.8 divided by 138.13. Okay, 0.7587. This would be moles. And then that's the C7H6O3. Most likely the salicylic acid is the limiting reactant, but let's see. It's more expensive, so normally you would expect that to be the case. We're also going to react it, going back to the original question, with 110.9 grams of acetic anhydride. Acetic anhydride is C4H6O3. Okay, so 1 mole of that weighs 102.10. Okay, so 110.9 over 102. So 110.9 divided by 102.10. 1.086. Now here's what happens. Since the stoichiometry is 1-to-1 to 1-to-1, everything's a 1, it actually makes the calculation quite a bit easier. Whatever is the smaller number of moles is the answer to the amount that will actually be produced. So here's what I'm going to do. I'm going to show this to you here. If you have this many moles of the salicylic acid, it's more expensive than acetic anhydride, so that's the reason that it's the limiting reactant. Take a look at the equation. On the product side, let me just move this up here. Oops, sorry. On the product side, this is a 1, this is a 1, and this is a 1. So the stoichiometry is 1, 1, 1. So it's times 1 mole of the aspirin, C9H8O4, divided by 1 mole C7H6O3. Right, so you're going to get that same number. You're going to get 0.7587 of the C9H8O4. That's the smaller number than you're going to get for the next one. If I do the same calculation with the acetic anhydride, it's 1 mole of C9H8O4 for every 1 mole of C4H6O3. That's what's called a 1-to-1 ratio. It occurs quite commonly. 1 of these for every 1 of those. Okay? So you're going to get 1.086 C9H8O4. You pick the smaller number. This is the smaller number. For the limiting reactants, the one that's smaller. So we're going to use that number right there. So that means we've got 0.7587 moles of aspirin, or acetyl salicylic acid, if you want to call it by its more technical name. Okay? How much does it weigh? Well, it's 180.17 grams per mole. We already figured that out, right? So if we multiply this by 180.17 grams per mole, so 0.7587 times 180.17, you get 136.7. There's your theoretical yield. Okay? The theoretical yield is the mass that you calculate using the limiting reactant problem. So it's 136.7. So now we can come back to the beginning. 105.6 over 136.7 times 100. Okay, so 105.6 over 136.7. It's about 77%, 76.7%. A little low. Usually it's in the 80s or 90s, but in the 70s in any case. Okay, so there you go. 105.6 over 136.7. That means that we roughly made about 3/4 of what we would expect to make if all of the reactants, or at least all of the limiting reactant, had successfully been converted into products. 77%.